Hi, I'm Lee Teschler with Machine Design Magazine. We're here with Dennis Scorscia from Fluid Metering Inc. Dennis is going to tell us a little bit about the technology behind a valveless piston pump. Dennis, tell us a little bit about this technology.
What we have here is the FMI pumping principle, which is a valveless positive displacement piston pump. And on the display, we're showing exactly just how all of our pumps work with this one demo. What we have is our valveless piston design. As you can see, when it's in the center, the piston is directly coupled to the drive, so there's a natural rotation. By moving the blue indicator one direction or the other, we reciprocate and rotate at the same time. You'll notice there's a flat at the very bottom of the piston. That's what's alternately opening and closing your two stationary ports. So by going extremely to one side like so, the piston is rotating up. That's when we self-prime. We'll lift 15 feet of fluid or gas. Sealing it, simultaneously opening up the other side. Now, as downstroke, we discharge where positive displacement will go up to 100 psi. By moving the blue indicator towards the center, we're shortening the stroke, thus taking less fluid in, less gas, and giving us a smaller calibration. Center line is 0. No more pumping action, just going to rotate around. The other side, reverse, or reverse the rotation of the motor. In the pump head itself, there's only one moving part, giving you a lot of online reliability.
What exactly would you use this kind of metering technology for?
And these are used in many different areas. We do a lot of OEM work where we deal with a lot of clinical chemistry, blood analyzers, the Abbott Labs, the Beckman Coulters, the Ortho Clinical Diagnostics, all the reagent feed pumps that are in there that they run the blood through to get the tests for all of us. Our pumps are in there because of the high accuracy that we have, which is better than plus or minus 1%, and the precision is better than 0.5. So because of that factor and the online reliability, it keeps a nice even baseline for all these tests that need to be done, and we make sure we're all the same no matter where we are in the world.
How much fluid can you dispense with this method?
We could go anywhere from a half a microliter per dispense to a little over a gallon a minute is our dynamic range. And we are, as you can see from the display, viscosity independent, because here we're moving water, air. Here's a ultrasound gel, which we actually make little packages for them in the medical field, in the doctor's office and such. And here's the water, and I don't know how close you can see that, but that's our smooth flow. They use that for coating stents and things of that nature. The one on the very end over there is, you'll see two different size droplets. Again, off of one unit that has two pumps in there, independently being controlled. So we could do lots of different ratiomatics, ratio feeds and so forth, or just doubling up as far as having a larger volume that we need to pump and meter.
So you basically have one piston that both moves the fluid and meters it at the same time, right?
Correct. Our pump will do metering, dispensing. Actually, our forte is long-term, drift-free, accurate metering and dispensing. They'll run intermittent or 24/7, 365. Does not matter to fluid metering. And we could have wooded components of just ceramic and Teflon.
Does the viscosity of the fluid matter?
We're viscosity independent under the right conditions. As I say, you can see we're pumping an ultrasound gel, and believe me, there's gas bubbles in there and air and things like that, but we'll continuously meter it. Under the right conditions, we'll meter peanut butter. So again, like I stress, under the right conditions. You may have to heat, thin, or pressure feed it. The main thing is not to cavitate our pump. So our inlet side is the most important. Discharge, because we are positive displacement, doesn't matter. As long as there's enough power with the motor, it'll overcome it.
What kinds of things would cause cavitation?
Cavitation will be because when the fluid cannot be kept up with the pump itself. The moment we start to get any resistance on the inlet line, because the pump is calibrated for what it's set for, it only knows one thing, and that is to move that volume. And if I can't move that volume, the first thing it's going to do is degas whatever solution it is that I'm pumping. So it's as good as the line or its smallest orifice on the inlet side of the pump. It may not be the tubing itself, it could be what it's connected to, like in a vessel that may have a very small orifice. That would be my point of restriction. So the moment I cannot keep up with the fluid, the pump can't keep up with the calibration, that's when we're going to start to degas solution, thus causing cavitation.
What would be the smallest amount of fluid that you could work with in this kind of technology?
We could do a half a microliter per stroke, so depending on how many RPMs of the motor that you want to deal with, we have different types of drives that we offer, from stepper technology up to continuous feed or continuous motors, RPM motors, and also variable speed type. So based on a half a microliter times the RPM is going to be my lowest that I'll go.
What's the toughest part of metering this way?
It's something. It's simple the way it looks because it's one moving part. But then you always ask yourself the question: well, you know, what are the things that, you know, how simple is simple? There's a lot of things that take place in fluidics that always come up. It could be anywhere from the type of material that's being pumped, the tubing size, the tip size. In some materials, because they are viscous, when they go to dispense, let's say, you don't have that clean let go at the end of the tip, so you may have to cut it or a touch type, or in some cases we even have what they call a suck back. After it dispenses, we have because we use stepper technology, we can actually bring it back a few steps, bring it back